Assalamualaikum. My name is Ali Mirzan bin Muhammad Zain, and today I will present about my project, which is face verification using a Siamese network. So, for the introduction, this project will focus on a face verification using a Siamese network, which compare the two face image to check if they are belong to the same person or not. Unlike the normal classification model, the system does not predict a name, but instead measure a similarity between the two faces. The model learns facial feature using a shared convolutional neural network, which is CNN, and compare them using a distance. Okay, next. So now I will present about a model architecture. This diagram is a Siamese network used for a face verification. It takes two input image, which is image A and image B, and pass both of them through the same convolutional neural network, which is called as a CNN. Inside of this network, the conv layer plus ReLU is used to extract the important feature from the image, where the convolutional layer detect the pattern like edge and facial feature. And ReLU help the model learn by keeping the useful value. After the feature extraction, each image is converted into 128 dimensional embedding, which is a vector of number that represent the key characteristic of the face. Because both of image use the same network, the features are learned in a consistent way. The model then calculate the distance between the two embedding to measure the similarity. If this distance is small, the faces are likely from the same person, and if the distance is large, they are different person. Finally, the distance is used to make the output decision of whether the two input image belong to the same person or different person. Okay, next. Now I will present about a workflow diagram. So this workflow diagram show the full process of my face verification system using a Siamese network from the start until the end. First, the system collect all the face image and organize them by each person. Then, all of the image are pre-processed by resizing and normalizing them so they can be used for a training after that. The system create image by pair, including positive pair which is a same person and negative pair which is a different person, and split the data into a training and testing set. Next, Siamese network is built and trained using a contrastive loss, so the model can learn how to compare the two faces. After the training, the model will be evaluated, and the best threshold value is a select to decide the whether two faces are same or different. In the final stage, the face verification system take two input image, pre-process them, and extract the feature using a trained model. Compute the distance between them and compare this distance with the threshold to output whether the face belong to the same person or different person. So now I will present about a loss function. In this project, I use a constructive loss because the Siamese network compare two face image instead of classifying one image. So the goal of this loss is to make the distance small for the same person and to make the distance large for the different person. So this is loss function for this project. In my code, the function constructive loss take the true label, which is y true, and then predict the distance, which is y pred, as a input. If the pair is the same person, y true equal to 1. The loss use the square distance to reduce it. If the pair is different, y true equal to 0. The loss use a margin to push the distance to be a larger than that margin. Finally, the average loss is calculated to update the model during the training. This constructive loss is suitable because the face verification is not normal classification. The model does not predict a name or class directly. It learns whether the two faces match or not by compare their distance. Okay, now I will present about a justification about why I use Siamese network and the tool used in my project. So the reason why I use Siamese network because Siamese network is suitable because it's compared to image directly, which match the face verification task. It also does not require a fixed number of class, so it can recognize the new face without retraining. The model also learns the similarity between the face, which is more effective than traditional classification method. It's performed well, even with a limited training data, since it uses an image pair instead of many label class. So the library and tool I use for this project is first Jupyter Lab. I use Jupyter Lab because it is used to write and run the project code step by step in an interactive environment. Next tool I will use a matplotlib, which is to display the image and plot the graph such as a training loss during the model training. Next, I will use a tool OpenCV, which is used to read the image, process the image, capture the webcam input, and perform the face detection. And last tool I use is a TensorFlow, which is used to build and train the Siamese neural network model, which is a CNN. In a conclusion, the model architecture use a Siamese network with a shared CNN to extract the feature and compare two face image using a distance. The workflow diagram show the complete process from a data preparation, model training, to final face verification and a decision making. The loss function, which is constructive loss, will help the model learn the similarity by reduce the distance for the same person and increase the distance for different person. The justification show the Siamese network is suitable because it compare the two images directly, work with a new face, and perform well even with a limited data. So that's all from me. Thank you.